Hi all. In the last video, we saw the importance of designing drilling hydraulics for a safe and efficient drilling operations. For designing drilling hydraulics, three essential things are being necessary. That also we discussed briefly, mentioning about the importance of maintaining the hydrostatic pressure and the necessity for choosing the proper flow pattern along the pipes, fittings, and annulus, and also we have to determine the proper rheological properties of the drilling mud and choosing the types of fluid based on the geomechanical situations. So in this video we are going to see about the types of fluid flow. So the fluid flow is something related to the way the fluid particles forms the pattern inside while flowing through the pipes, fittings, and the annulus. So that can be many fluid patterns can occur, which can be broadly described as laminar, turbulent, and transition. So this laminar, turbulent, and transition fluid pattern also in one other way the other affects the rheological properties like mud density and the fluid viscosities, because it involves in rotations, vibrations of the fluid particles that we will be discussing in the next lecture. So, as mentioned earlier, like there can be a laminar flow or turbulent flow or transition flow. The definition of a laminar flow: the laminar flow means the each and every fluid particles in the fluid has a particular direction. The directions will be along the direction of the flow, and the fluid particles will be flow parallel to each other, and there won't be any interchange of energy or momentum, or there won't be any mixture of the fluid mixture of any properties of the fluid particles from one layer to another layer. It means that fluid particles will flow parallel along the direction of the flow like a layerly flow, and there won't be any kind of mixing kind of patterns occurring in the fluid flow. But the other way around, the turbulent flow behavior would be like kind of it normally occurs at a very high velocities. During that high velocity, uh, and in addition to the primary flow of fluid particles along the direction of the flow pattern, there will be like secondary flow patterns which are very irregular, such as vortices and eddies imposed into the primary flow. So this causes like kind of a chaotic movement of the fluid particles while along the fluid flow, and there won't be an orderly shear as like similar to the laminar flow, like layer to layer. There will be like kind of a disordered kind of fluid patterns or fluid layers will be presented in the turbulent flow. So how do we determine whether the fluid flow pattern occurring inside the pipes or annulus is laminar or turbulent? Uh, that normally determined by a dimensionless number in the fluid mechanics called Reynolds numbers, which is a very fundamental properties of the fluid dynamics. There are many dimensionless number like Mach number, Prandtl number, and so many other dimensional numbers. But this is a very critical, crucial dimensionless analysis of the fluid flow called as Reynolds number. And when it can be determined through certain properties of the fluid flow and also the properties of the fluid. For example, for a flow through pipes, the Reynolds number is described by 4.9, which depends upon the flow rate and the geometrical properties of the geometrical properties of the pipe. And also for the flow through annulus, it also depends upon the flow rate, geometrical properties of the annulus, and also the fluid properties like density and the viscosity. So this is like a flow rate which calculated from the this is a flow velocity which is calculated from the flow rate, mean fluid velocities. So there would be a critical number like around for every design for internal flow or external flow. For a pipe and annulus for normally there will be a critical Reynolds number around 2300. Below that will be termed as laminar, and above that above certain value it will be determined as not laminar flow like transition flow or turbulent flow. So For a drilling engineering purposes, we have like a threshold like around 2000, below which it is clearly we can say that flow pattern is laminar. And once it crosses 2000, it makes a transition from laminar, and up to 4000 it's called termed to be as a transition flow. And once it crosses 4000, the turbulent is fully developed, and we can determine term that fluid pattern as a fully turbulent flow. So Reynolds number is a very critical dimensionless analysis for the determining the flow pattern. So the flow pattern will determine how the transport of the cuttings taking place, and how the friction losses taking place along the pipes and annulus, and by analyzing the friction losses, how to determine the mud density, and that mud density will determine the hydrostatic equivalent mud weight of along the depth. That will determine how to avoid how to exceed the hydrostatic pressure to become greater than the formation pressure. Then will give you the stability of the drilling hole. So this all indirectly helps us to understand the safe and efficient drilling operations. Hopefully, we'll see about how the rheological properties of the fluids is affecting the designing of the drilling hydraulics. Thank you.